Greetings fellow game developers, Vadimsky here. Let's learn about Unity data-oriented technology stack. What does this mean for Unity? And most important, why should we care about it? I'm gonna start with a bit of theory, and gradually move on to the real-world examples. Unity presents data-oriented stack as a high-performant multi-threaded solution for all our problems. They even rewrite the Unity engine code with the data-oriented approach in mind. This includes reworking network, physics, animation, and so on. And even though right now DOTS is in early alpha phase, Unity is pushing hard. You might ask why? Well, it turns out that object-oriented approach we are used to is inefficient when it comes to CPU cache memory usage, and that leads CPU to rely on RAM memory, which is much slower than L1 cache lengths. If you want to learn more about data-oriented approach, you should check out Mike Acton's presentation on YouTube. It's a great presentation and a good place to start. So let's get back to DOTS. With DOTS, they introduce three core systems. First, the Entity Component System, ECS, which is a design pattern and is pretty convenient to use with the data-oriented approach. The second is C# job system, which lets you write simple and safe multi-threaded code. And the Burst compiler, that translates your C# code to highly optimized native code. If you stick with me, I'm gonna show you how to enhance your already existing project. So let's get into the real stuff. In this video, we will focus on the DOTS training samples. It's a collection of demo projects to be converted to Unity DOTS. If you're familiar with job system or Burst compiler, I encourage you to try it first by yourself, and then come back to this video. So let's look up to the samples projects available. Links for this repository will be in the description below the video. For example, I chose Factory project. It's nice and simple, and it's easy to understand what is going on about. So how do you download and set up Git project? I like to use an app called GitHub Desktop. It trivializes the whole cloning and downloading experience, which we should not care about in this video. So just open GitHub Desktop app, choose File, Clone Repository, and just paste the link we got from the GitHub webpage. Hit clone, and it's all done. Next, open up downloaded Factory project and let's install job system and Burst compiler dependencies. For this, you just open Package Manager window and search for collection package, and make sure you enable Show Preview Packages checkbox. After that is done, let's open up main theme. And as a side note, let me show you some changes that I made for this project. Depending on how clean the project was written, the changes you need to implement should be minimal, but in this case it was a mess. It's like a man who wrote this didn't know anything about separation of concerns, or just didn't care about it. So all I did is change C# arrays and list to native arrays and native list. Also changed a class map to struct map data store. It's because Burst compiler doesn't work with managed types, so instead of classes we should use struct data types, and instead of system collection arrays we should use native collections. That's all I done. No changes to the app logic was made. Also, I increased max bot count to 10,000 and number of bot spawn when we click on game field to 50, so we could stress test this game to the limit. Now let's run it and see what we get in the profiler window. So there is 50 bots spawning every update cycle while I'm pressing the mouse button until we reach 10,000 of them. As you can see, with maximum entities on board we get around 6 frames per second, and 95% of computing is in bot manager update method. So let's dig in and figure out how we can improve it. After a couple of minutes of researching, I found this method called generate from the flow field class. And on low entities count, this method is taking around 50% of update computing cycle. So let's open Factory Manager class, go to update and to generate flow field method. As you can see, there is plenty of logic in here, but we shouldn't care about it. Our goal is to optimize this piece of code with minimal effort. And I'm gonna accomplish this just by copy and pasting generate method logic inside a job. So let's write generate job struct, and don't forget to implement iJob interface. Next, let's select and cut all heavy logic from generate method and paste it to execute method of our new job struct. You'll see some error going on. That's because we need to duplicate all the dependency variables to our job too. So just copy all these fields and paste them to the job. Now when everything looks fine, let's instantiate and run this job instead of the old logic. It's a straightforward process. You create generate job instance, pass it all dependency and execute method run. Let's see the result we got. So from 10 milliseconds to 0.1, that's about 100 times faster. It's pretty good, considering that all we did is move logic from one place to another. Now let's see how can we furthermore optimize our logic. From our first stress test, we all saw that 95% of computing is done in bot manager update method. But this method is too large to just copy and paste. So let's split it to small parts. I use methods begin_sample and end_sample, so we could see in the profiler how much computing time is spent on each part of the logic. Now let's run and test it. It looks like the transform part of logic is doing around 80% of work. So we know where to start. Open bot manager update method and locate the transform part. This for cycle is using array of factory bots object. As you can see, the factory bot struct has all these manager type classes as a dependency fields, so we could not use it inside our job. What we can do is create struct called bot values, which will contain partial data from factory bot object. This data is what we will be using inside the job. Now let's create bot transform job struct and copy all this logic in there. Next, let's fix some errors by creating missing job variables. After it's done, all we have to do is create and run bot transform job. Since we are not passing factory bots array, but instead a native array of bot values object, we need to create temporary array. Copy all values that we will be using inside the job, and after the job is done, copy values back to the factory bots array. Don't forget to dispose temporary array after job is done, otherwise we can have memory leaks. Let's see what we accomplish here. This doesn't seem right. That's because we forgot to add burst compiler attribute to our job, and it's this attribute that does all magic for us. Let's run it again. Now looking much more better. And we can move out to the next piece of logic, which should be the bot sort part. So we open bot manager class and locate it. The logic for converting this part to the burst job is the same as the previous part. You could expect similar result as you can see now on your screen, and the job running code should look just as the previous example. All we have left to do is just play the game. So we came from 6 FPS to almost 40. I call it impressive, and it all came from Burst compiler. It looked like Unity done some heavy magic on this, and despite the new package being in the early development cycle, it's safe to bet we think Unity will continue to move in this performance first direction, and we can all start benefit from it today. And that's pretty much all I wanted to show you, so thanks for watching. Don't forget to like and subscribe for more content like this, because next time I will show you how to use new Unity Network package. Stay tuned.